Through the eyes of NASA. Today, we start with a view off the coast of Oregon from Gulfstream 3 aircraft out of NASA's Armstrong Flight Research Center. This coastline is where the eclipse will soon begin, starting on the west coast, then tracking the eclipse as it moves to the east coast. We will bring you the experience of 2017 eclipse across America. We invite you to join us for exclusive eclipse programming from coast to coast across the country. Welcome to NASA's pre-show coverage of total solar eclipse of 2017. We're coming to you live from NASA Eclipse Central at the College of Charleston in South Carolina. Over the next 4 hours, be prepared for an amazing journey through the eyes of NASA. Now, on to our pre-show hosts, Karen Fox and Sean Potter. Guys, take it away. It's sun time.
Thanks, Dwayne.
Thank you, Dwayne. We have a great show for you today. I can't wait.
No, me neither.
Can't wait.
Hear those bells? That means it's eclipse time, right?
Welcome to NASA TV's broadcast of the 2017 solar eclipse. I am Karen Fox, NASA's communications lead for what we call heliophysics. That's the study of the sun and how it affects space.
And I'm Sean Potter from NASA's Office of Communications. I'm also a certified broadcast meteorologist, so today I'll also be tracking our eclipse weather for you.
And as you can see, we are at the College of Charleston in South Carolina at NASA Eclipse Central. From right here, starting at 1 p.m., we will be tracking and covering today's big event, Eclipse 2017.
Today, millions of people across the United States will witness a spectacular event, a total solar eclipse.
As the moon crosses the face of our sun, we're going to be bringing you real-time, breathtaking images in locations across the country. NASA TV has cameras, telescopes, balloons, aircraft, and even spacecraft standing by to bring you views of this natural phenomenon. So get ready to look through the eyes of NASA.
Plus, coming up at our 1 p.m. broadcast, we have NASA experts standing by at locations across the country. They're going to be highlighting views of the eclipse and also pointing out how NASA is using the eclipse to study not only the sun, but also our Earth and its atmosphere.
Now, all of North America will experience a partial eclipse. That's where the moon blocks only part of the sun. A total solar eclipse is going to sweep across the nation along a 70-mile wide path arching from Oregon to South Carolina. This is called the path of totality, and people along that path are going to experience the glorious sight of a fully eclipsed sun.
But first, I want to take just a moment to remind you of some very important eclipse safety tips. First of all, never, ever look directly at the sun. It's not safe for your eyes and could cause damage.
It's really important, and we're going to keep sharing safety tips throughout the broadcast. But for now, let's take a look at today's weather.
That's great. Okay, so what we're going to do right now is we're going to show you an image from the GOES-16 satellite. This is the latest and greatest weather satellite that NASA built and launched for our partners at NOAA, the National Oceanic and Atmospheric Administration, just last year, and it's going to revolutionize weather forecasts. And you can see it's a very detailed picture of cloud cover across the country. And actually, for the path of totality, which remember stretches from Oregon across the midsection through Nebraska and Missouri into parts of Kentucky and Tennessee, and then exiting the U.S. here in Charleston, looks pretty good except for the midsection of the country. Maybe Nebraska and parts of Missouri might see some cloud cover, and then as you get here toward the coast in Charleston, as we look up, we do see some clouds. So we'll keep an eye on that and have more for you later in the broadcast.
Crossing fingers for weather here. An eclipse is something called a transit. A transit is when one celestial body appears to move across the face of another celestial body. And today, that is our moon moving across the face of the sun.
And it's almost time for that transit to begin. 12:05 p.m. Eastern Time, that's 9:05 a.m. Pacific Time, will mark the beginning of the eclipse over U.S. soil.
So let's go right now to Salem, Oregon, to hopefully catch a glimpse. There's a large celebration underway, coordinated by the Oregon Museum of Science and Industry. Jesse Carpenter from NASA's Ames Research Center is standing by.
The corona is so hot. That's like if you were standing next to a fireplace and as you moved away, it got hotter, which is crazy. But we know that it's from those dynamic magnetic fields that we're seeing here.
Okay, I just got word that we haven't started. Okay. Okay, I guess we're going from the top.
All right, thank you to Ames.
Thanks, Jesse, and so we begin our eclipse coverage. Also coming to us from Oregon is this stunning image from a telescope located in the town of Madras. In partnership with NASA, the Exploratorium is providing telescope feeds available as a live stream. This makes spectacular views available to everyone. Now, the Exploratorium is a public learning laboratory that explores the world through science, art, and human perception.
So let's talk a little more about that science and what it is that we're actually going to be learning today. A lot of people think that space is completely empty, right?
Yeah, a lot of people.
And it's not quite true. We actually live in the extended atmosphere of an active star. Heliophysics is the study of our star, the sun, and its effects on space. So the sun sends out solar material, and it helps drive this constantly writhing magnetic system throughout space. And this system surrounds Earth and the planets and extends far out into the solar system. So NASA studies this system not only to help us understand more about our place in the universe, but it also helps protect our technology and astronauts in space.
So now let's go to Carbondale, Illinois, where NASA Edge is standing by to tell us more. Actually, we're going to stay right here at Eclipse Central in Charleston. So Karen, I'm going to hand it back over to you.
So this is a good time to take another moment to talk about safety. Now, first and foremost, never look directly at the sun. It's not safe, and it can cause damage.
But there are lots of ways to safely view the eclipse without looking directly at the sun. Be sure to visit eclipse2017.nasa.gov for detailed instructions and advice.
Now, you may have seen these eclipse glasses, right?
I got my pair.
They are designed with special purpose solar filters.
So ordinary sunglasses, even very dark ones, are not safe for looking at the sun.
Now, even if you don't have glasses, you have options. For one thing, you can share glasses, right? This event, here, take my glasses,
We're
Sean.
going to share, yeah.
This event lasts for hours. Now, you can also make a pinhole projector. This is simple. You can literally just take a piece of paper, you take a pencil, you punch a hole in it, you put the sun behind you, you hold up your paper down like this, and you're going to be able to see an image of the eclipse on the ground or maybe on a wall if you project it onto a wall. It's really simple to watch the sun safely.
Lots of options available to you no matter where you are. There's lots more information about how to watch an eclipse. Again, that website address is eclipse2017.nasa.gov. It's the only time that's safe to take these glasses off when you're looking at the eclipse is if you're in the path of totality during the brief few minutes that the moon completely blocks the sun. Let's watch this video to learn more.
On August 21st, 2017, the Earth will cross the shadow of the Moon, creating a total solar eclipse. Eclipses happen about every 6 months, but this one is special. For the first time in almost 40 years, the path of the Moon's shadow passes through the continental United States. Everyone there will see the Moon at least partially block the Sun. People within the path of totality, shown here in red, will witness a total solar eclipse. For them, the moon will cover the sun entirely. The sky will become twilight, the air will cool, the stars will appear, and the black disk of the moon will be surrounded by the pale, streaming halo of the sun's corona. Totality will last for 2 minutes or a little more, and it will be visible along a swath that crosses the continent, from Oregon to South Carolina. For some, it will be the spectacle of a lifetime.
Coming up during our 1 p.m. broadcast, we will have a live demonstration with a pinhole viewer and more ways to safely view today's eclipse.
NASA TV is going to be bringing you real-time, breathtaking images. In locations across the country, we have cameras and telescopes and balloons and aircraft and even spare spacecraft standing by to bring you views of this natural phenomenon.
Got it all. I can't wait. But right now, let's take a minute to learn about one of the aircraft being used today. NASA's Armstrong Flight Research Center operates a Gulfstream 3 airplane for aerodynamics research and mission support. Today, their flight path is taking them over the Pacific Ocean to see the very first view of the total solar eclipse as it begins to cross the country.
Let's watch this video to learn more about their eclipse mission.
NASA's G3 aircraft out of Armstrong Flight Research Center will feed the world live video coverage of the eclipse from the west coast of Oregon as it begins its path across America. So we hope to bring that view through the eyes of NASA. We go out there and modify aircraft all the time so we can go out there and do NASA science. It's what we do. In the case of this aircraft, we've gone out there and taken the normal passenger windows and replaced them with optical grade windows, plus put in a telemetry system so we can go out there and provide real-time video. With these optical grade windows, it allows our photo and video teams to go out there and capture high-resolution video at 35,000 feet to present to the world this rare event. And using this event to go out there and educate people, I think, is an exciting proposition.
All right, it's just about the turn. We'll be almost.
From a pilot's perspective, we want to make sure we get to the right spot, and also there are limitations for what our photographers can do.
Okay, roll out here.
We pushed it as far west as we could go so we could get that as early as possible and as low in the horizon as possible. And that put us at about Lincoln City, Oregon, which is the farthest west point right on the west coast. So we set up a holding pattern or a racetrack pattern right over Lincoln City. We know exactly the width of the totality swath. With that, we did some mission planning again to make sure we know what the stall speeds are, the slowest speeds, the safest speeds to fly, the speeds that will give us the most time inside the totality region. We can slip the airplane. That'll give us some more bank angle, which lets our cameras see a little bit higher. So all of those kinds of things were what went into from a pilot standpoint, planning this out.
All right, you guys ready to turn in again for a partial?
I think it makes us proud of what we do and that we're able to share it with everybody around the world in this case, due to the modifications to the airplane we made. That's what we do.
How you doing, Coop?
Great.
Wow.
I can't wait to see what that G3 is going to show us today.
That was amazing, and it's going to be an incredible view, the first view of the solar eclipse as it's literally crossing into the United States.
So basically it is off the west coast right now, so it's getting a view of the eclipse before we even get a view from land. of that partial eclipse.
And that G3, it's just one of a fleet of NASA aircraft and observation platforms that we have. We've got, as we mentioned earlier, satellites, both ours and some from some of our partner agencies, aircraft, the balloons that we've got, and we'll be telling you more about that in our 1 p.m. broadcast as well. But we've got you covered here in terms of, Eclipse, not only looking at it from the ground, looking at it from the sky, looking at it even from space. I don't know if we can get a little preview to that.
Great. And you know what I just heard? We've got the Salem, Oregon eclipse starting. This is the partial transit, and we're going to the G3 now to see what they
Live
can
to the
see.
G3.
We've got an exclusive feed as they fly over the Pacific Ocean, and Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Do we have Kevin?
Okay.
All right, he's going to be up soon.
But you can see, and we actually have a monitor here on set in Charleston, so we can actually see what they're seeing live, and you can see the transit beginning as the moon is just starting to eclipse the sun. Isn't that an incredible image, Karen?
No, it's beautiful. And so just to be clear, what you see on the screen right now, is that partial transit. The partial transit can take, the partial eclipse can take, up to 3 hours, a little bit longer in any one location. Whereas the total eclipse, that's only about a minute and a half, 2 minutes.
Right. A lot of people talk about the totality, only lasting maybe at most 2 minutes or so. But sometimes people don't realize that in terms of the entire eclipse, from the very beginning of when the moon starts to cross over the sun's surface till the end is actually much longer.
Yep.
Okay.
Great. So let's talk a little bit more about these eclipses, because I want to tell you one of the things that I think is one of the cool things about total solar eclipses. We're the only planet in the entire solar system that can see them.
The only one.
The only one. Earth is the only planet where the moon appears to be the same size in the sky as the sun. And that's really just a great cosmic coincidence.
That's right, Karen. The sun, believe it or not, is about 400 times wider than the moon, but it's also about 400 times farther away. Now that geometry means that when they line up just right, as they are today, the moon blocks the sun's entire surface, creating a total solar eclipse. Let's take a moment to learn more about that geometry.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. It has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
Wow, that was amazing. So now we've got a live shot from that G3 aircraft looking out the window
and
as the eclipse begins.
We're going to be seeing the eclipse live from this G3. It's 35,000 feet up in the air.
Over the Pacific Ocean, as the eclipse begins, very interesting to see how they had to sort of retrofit it with the special glass to get the best viewing possible. And I'm sure it's an exciting moment up there. I can only imagine what the folks inside the G3 are feeling right now.
Great, and coming up we will have some live interviews from the G3. And now we are once again looking at the eclipse from Salem, Oregon. So to all the people who are out there in Oregon, this is what they are getting to see right now, that first little glimpse of the moon. It almost looks like a bite out of a cookie, right? Oh, first glimpse of the moon passing in front of the sun. Now Salem is in the path of totality, so they will have a chance to see the full eclipse.
And they've got great weather from what I can tell, and certainly a good shot from this telescope there on the ground looking at the eclipse. It's amazing. And just a reminder for folks, we can't say it enough, stress it enough, the safety aspect. If you are anywhere, whether in the path of totality or not, you've got to have those glasses, even if you're looking at a partial eclipse, even if it's cloudy. All right. When depicting an eclipse path, data visualizers have traditionally represented the moon's shadow as an oval.
But for today's eclipse, for the first time, NASA visualizers were able to show that the moon's shadow is actually better represented as a polygon. And this more complicated shape is based on several NASA observations, including information from NASA's Lunar Reconnaissance Orbiter, which is currently orbiting the moon as we speak right now. The spacecraft has a unique view of the mountains and valleys that form the moon's jagged horizon.
Let's learn more now about mapping today's eclipse using NASA's unique data sets.
What we're talking about is several visualizations of the path of the moon's shadow during the eclipse in 2017. Everything in it is driven by the data. So the color of the ground, the position of the path of totality, the lighting from the sun angle, all of those are things that are based on data. A lot of NASA products were used to create this visualization. I used the Lunar Reconnaissance Orbiter, the laser altimetry data from that, which gives us a digital map of the elevations on the moon. For the Earth, I used something called SRTM. This was a radar that was flown on the space shuttle. For the positions of the Earth, the moon, and the sun, I used a JPL ephemeris. An ephemeris is just a list of positions, but it's the most accurate tabulation of those positions. This visualization is unique because it shows the effect of both the irregular edge of the moon, the limb of the moon we call it, and the elevation of the observer. Now, we've known for a long time that the elevation of the observer affects where the shadow is. We've also known that the mountains and the valleys along the edge of the moon affect the shadow. So you may have seen on eclipse maps in the past that the image of the umbra, that shape of the shadow on the Earth, is drawn as a smooth oval. But we know that the moon isn't smooth. Around the edge of the moon, we have these sort of jagged peaks and valleys. And a peak can block the sun a little bit earlier than you thought, and a valley can let the sun in a few seconds longer than you thought. The combined effect of these peaks and valleys is to create a shape that's not really an oval, it's more like a polygon. But it hasn't actually been seen in exactly this way before, where we calculate those circumstances for every point on the map and draw that shape. Totality is that 2 minutes when or 2.5 minutes when the moon completely covers the sun. The sudden darkness of totality is just something that a lot of people can't compare to anything else. I love the idea that I'm giving this kind of map to other people, and especially that it's more detailed and more accurate so that people are actually in the right place to see it.
So there's a lot of great science being done today, and this eclipse provides an opportunity for researchers to test innovation for future NASA missions too. NASA scientist Nat Gopalswamy and his team pursue eclipses because when the moon completely blocks the bright light of the sun, it reveals the corona, which is our star's faint outer atmosphere.
And this year, scientists will test a special kind of camera. The team will only have 120 seconds to complete an experiment that may one day change the design of sun-observing spacecraft.
Let's learn more about how this team of NASA scientists is chasing the sun.
corona can be studied from ground-based telescopes only during eclipse. When our eclipse happens, we make use of it and try to test some of our ideas.
Yes.
We have only 2 minutes to do the experiment, and we have been preparing for maybe more than a year.
Nothing can go wrong. Your camera can't shut down, you can't press the wrong button, and because there's no time to change your mind or make alternate decision.
We are going to set up the telescope and observe the total solar eclipse at 4 different wavelengths, and the images taken in these 4 different wavelengths will be used to determine the temperature and flow speed of the corona.
We are planning to take these images using a polarization camera, which will be a first for us. I think it's the first for the solar physics community. So once the moon completely covers the sun, the experiment begins. It's my job to make sure that the image is in the field of view. So at the correct time, one person has to give the command to turn the filter wheel, and for each filter there's a different exposure time. So another person has to enter the exposure time.
Running 3850 right now.
It's a combined effort of 6 different hands. No one person can make any errors.
8121. We do feel the pressure and also the excitement of the eclipse. Still, we have to focus on our experiment. Hey, all done.
It gives a tense feeling, but I believe we'll succeed.
All right, we got another beautiful shot here of Oregon, and we're getting ready to start showing you imagery from around the country.
That's an amazing shot. And right now, we're going to toss it to NASA Edge, who is standing by in Carbondale, Illinois.
Tell us a little bit about that, because if you've received social media questions about it, you have the data point to respond to that.
Yeah, you know, honestly, when I first saw the eclipse, before the eclipse, I was like, well, I've seen lunar eclipses, I've seen partial eclipses, probably similar in experience.
Looks like Troy's been a real eclipse traveler. I didn't know this about you.
I'm an eclipse chaser now. It's like, but it was the first one I saw was in Turkey, in Side, Turkey, and the next one was in Micronesia. And when the eclipse happened, it was about 85% coverage, as I could see with my pinhole projectors and my glasses. At about that moment, I noticed the sky around me started getting noticeably dark, and the temperature dropped about 10 degrees.
We could use it.
Oh my, yeah, we're totally going to love that. And at that, right as the disk of the moon covered the sun, it was phenomenal. You're overwhelmed with an amazing feeling of being connected to the universe around you, because your vision is, you're seeing things differently, the shadows are changing, the animals are acting differently.
Yeah. Yeah, we know about that. I do want to take a quick moment to say that welcome our friends from NASA TV who are joining us from Charleston. Hope they have clear skies there. We clearly are having clear weather here.
We're having clear weather.
A little bit of clouds, but easy to manage. Great to have you guys joining us. Now, like I said, you have time to check this out, to see these sort of eclipse views. What other strategies could you share with our fans to prepare for the eclipse?
Just to basically, when the eclipse happens, spend all of your time with all the different devices and pinhole projectors before and after totality. The biggest thing that I would recommend is when totality happens, unless you have a camera set up on automatic, don't miss a second of the event. Make sure you are looking at the eclipse. Now, one of the things, some people forget to take their eclipse glasses off during totality, and they miss the whole thing there because they think it's unsafe. But you're not actually looking at the sun during totality. You're looking at the backside of the moon, which is pretty dark.
Yeah.
I mean, it's the darkest blackness you've ever seen. And at that moment, you will see the corona of the sun just magically appear across the sky, and you'll see several stars today. I think we have and planets. So we have the potential to see 4 or 5, I believe, planets and stars.
Okay, but you have to be pretty strategic at that point, right?
Yeah.
Because that's during totality.
That's during
totality. So you got to get your solar experience, and you got to swing your telescope around and see, or will you be seeing them with the naked eye?
You can see it with the naked eye during totality. Perfect. I recommend everybody look at it with the naked eye during totality.
Perfect.
But as soon as one bit of sunlight starts to come around the sun, trust me, it is super bright, and immediately put on those glasses and start using your pinhole projectors again.
That's a great point, and it's awesome because we're getting lots and lots of good science and good observational data to prepare everyone for how they can experience the events.
And you know something I have to tell you, we have a Flickr gallery that people are uploading many pictures to right now. So we would recommend and highly recommend that you go to the eclipse2017.nasa.gov site. You'll see the Flickr links there, and these beautiful images that you're seeing right now are images that were already uploaded just over the last several days.
Well, what's interesting is it's not just photos from previous eclipses. We're seeing lots of artwork, lots of really creative work. I think that's spectacular and a great part of what's going on during
is.
This eclipse.
People of all ages are ready for this.
It's fantastic. Well, I'll tell you what, Troy, thanks so much for coming on. When we come back later, you're going to share with us the results, right? And we're going to talk about that, right?
That's right.
And get more questions. Great. Well, right now, we're going to go inside the stadium to Kevin Boucher, who's with Greg Guzik from the Louisiana Space Grant Consortium, and they're going to talk about this balloon launch that they're going to provide for us. So take it away, Kevin.
I sure will. Thank you very much, Blair. Again, we are standing on about the 30-yard line in Saluki Stadium, and of course the stadium is filling up. And with me now is Dr. Gregory Guzik. And introduce yourself. Who are you with?
So my name is Greg Guzik. I'm a professor of physics in the Department of Physics and Astronomy at Louisiana State University. More importantly, I'm actually the director of the Louisiana Space Grant Consortium.
Okay, now what is that consortium? Who is it composed of, and what is its mission?
So the National Space Grant College and Fellowship Program was established by Congress in 1987. It's a nationwide effort. Every state in the Union, plus Puerto Rico and Washington, D.C. has a consortium. And for this project, there's a team, a collection of about 55 student teams placed from Oregon to South Carolina who are going to fly balloon payloads very similar to what we're going to fly here from Saluki Stadium.
And when I think weather balloons, I have this image. I think of one of my old Time Life series of books. The National Weather Service was launching a monstrous balloon. This balloon that in my memory was like 100 feet long, but yours are a little bit different. Can you talk about the structure of these balloons?
So these are normal balloons that the Weather Service actually uses, hence the name weather balloons. They're made out of latex, rubber. When they're fully inflated here on the ground, they're about 8 foot in diameter. And as we go up in the stratosphere, they'll expand to about 40 feet in diameter.
Okay, and if I believe right now on your television screen, I think you are actually seeing some data and video from these weather balloons. Oh, also earlier you told me you've been...
All right, thank you, NASA Edge from Carbondale, Illinois. I know you guys were asking about the cloud cover here in Charleston. Unfortunately, it is starting to increase as predicted. I don't know if you can see it over our shoulders here, but it's pretty cloudy right now. But that has not done anything to the enthusiasm of the crowd that's building here.
And now we've got that G3 aircraft, the one we talked about earlier. It's ready. They're 35,000 feet up and ready for us. We have an exclusive feed as they fly over the Pacific Ocean. Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Kevin.
She's pausing. Hi, welcome aboard. We're on NASA Armstrong's G3 aircraft right above the Pacific coast. I'm Kevin Rohr, and I'll be your host on the aircraft. And a big howdy, and thanks everybody on the ground that's making this shot happen. We've got a fantastic look out the window right now. We're circling above Lincoln City. We got a little bit of cloud cover down there, but we're going to have a fantastic view of the eclipse, and this should prove to be a wonderful day. With me today is Robert Lightfoot, Administrator of NASA, as well as Dr. Zabukin, Head of Science. And what we're going to do is cut to them really quickly so we can have a little discussion. And what are your impressions today, Robert?
Thanks, Kevin. What a great morning so far over the Pacific Ocean. We got to see the first bites out of the sun from the moon. Just an incredible view so far. I really want to thank all the teams that are out there all over the country helping us to get the most science we can get from here. Really going to be an inspirational day and hopefully inspire the next generation of scientists, engineers like me even in the current generation. Pretty inspirational from that standpoint. Volunteers everywhere, so we're excited about what's going on. And I got to turn it over to my buddy Thomas here. This is his field of study. So Thomas, what do you think so far?
Oh, it's amazing. We're already seeing it happening, right? Why do you think this is important to NASA and the United States?
Well, for us, it's a great opportunity. The totality across the continent, we're going to learn as much as we can. We study heliophysics and astrophysics in NASA, and this is a great opportunity for us to learn even more and have every instrument we have out there available to us to try to understand what we're going to see for the first time in 99 years. So just very, very exciting to see what we can do here and the observations that we're going to get. Can't wait to see the science come in and all the different science we're going to get from here. So, you know, everybody's going to learn something. So you tell me what you think you're going to learn, Thomas, having been studying this for your whole career.
Well, look, my field of study is the sun, and what's really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun, during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars we learn here first, but it's also a source of weather and radiation. And actually on board this aircraft we have 2 instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, and I think it's important. The more we know about the sun, the more we know about space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event.
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by applied physics lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here on the G3. Can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has 2 predominant lines. One is a really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are, about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes, affects the Earth and its turbulence. And, I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
Wow.
And that's great.
Amazing, yeah.
Thank you to those of you on the G3 to fill us in on what you're going to be seeing from there. Here we are on the other side of the country, here at Charleston, South Carolina. I want to give a shout out to the college. The students here have been so incredibly great for us, and we are actually going to have a chance to go back to Salem, Oregon, and find out a little bit more about what they are seeing there. They're talking about this moon picture right here.
Right, we've got a live picture right now from Salem, Oregon. We were showing you earlier in the broadcast, and as you can see, as we've been sort of describing it as the moon taking a bite out of the sun, it's continuing to happen, and what it looks like, Karen, is like it's almost like the sun. What we see is almost like a crescent moon, but it's not. It's the moon is actually the black portion in the upper right-hand portion of the sun that's being blocked out as we get closer and closer toward totality, which as Robert and Thomas said from the G3 aircraft, is only about 30 minutes away for folks in Oregon.
And we will go right to Madras, which is right near Oregon. This is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, you know, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks, we're talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as they mentioned earlier from the G3, about 30 minutes from now to totality there, about 90 minutes to get to where we are here in Charleston. So that means what? If I'm time's right, in about 2 hours, we'll be at totality here.
And we are now going to go to Salem, Oregon, where Jesse Carpenter will be talking to Nikki Weil, a solar scientist from NASA.
Welcome back to Salem, Oregon. It is clear, but yes, it is a little bit breezy
It's
here
windy,
today.
yeah.
Isn't it? Yeah. I'm joined again with NASA solar physicist Nicolene Weil.
Hi.
Hey, so why don't we just take a look at what we've got going on here now that transit is deep underway.
Yeah, so the moon is crossing in front of the sun, and it's kind of looking like the moon is taking a bite out of the sun. And if you guys have any colanders with you, like a kitchen colander strainer, you can actually see, if you let the sunlight come through that colander and look at the shadow on the ground below you, you'll actually be able to see the projected image of the moon taking a bite out of the sun down on the ground in front of you.
Oh, that's cool.
Yeah.
So you can just get something from the kitchen and share that with everyone who you're watching this with. That's great.
That's right. Now's the time to take out your pinhole cameras if you have those, or if you have those, you know, the safety eclipse glasses. Now's the time to get these out and make sure to look at the sun with these on.
That's right. You want to be watching safely. And I know we've been talking about it, but we really can't stress it enough. It's very important to be wearing these glasses.
It's just so amazing, though, to see the moon crossing in front of the sun. I mean, you never get to see anything like this.
So, are there some basics that you could share with us? I know we were trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So there's sort of three outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the atmosphere, the chromosphere and the corona of the sun. And we don't usually get to see those because they're so much less bright than the sun. It takes something special like today's total solar eclipse to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool. So I think what we're going to be doing now is sending it back to NASA's Eclipse Central in Charleston. Take it away, guys.
Thanks.
And welcome back to Charleston. You can hear these students are really excited for us. And I got to tell you, I had the chance to interview some of them just a few days ago. The College of Charleston students are excited, and I wanted to find out what they knew about the eclipse. Let's watch the video.
All right. So right now what we're looking at on your screen is
Hello, I am Karen Fox with NASA TV. I'm here at the College of Charleston in Charleston, South Carolina, and we are going to spend some time interviewing students to find out what they know about the total eclipse of 2017. What's happening on Monday?
The solar eclipse is happening.
Monday, the eclipse.
That's the right answer, the eclipse. Are you ready for the eclipse?
Oh, I'm pumped. I've been talking about it all summer.
What is an eclipse?
When the moon moves in front of the sun.
It's when the moon passes in front of the sun and creates a shadow on Earth.
What is the closest star to Earth?
The sun? The sun?
The sun.
The sun? Yes, the sun. Very nice. Will you demonstrate for me putting these on?
We're going to put them over the glasses.
the music you associate with the eclipse. What have you been listening to? What are you going to listen to?
Here comes the sun.
Total eclipse in my heart.
Do-do-do-do.
Da-na-na, like, I saved every letter you wrote me.
So I was really impressed with how much these students knew. We had a great time here. And now you can once again see the imagery we are pulling in of a white light telescope of 2 eclipses happening as we speak. These again are the partial eclipses, Salem, Oregon, and Madras, Oregon.
Right, as you can see, it's quite an image as that moon continues to progress. Transit is the term over the surface of the sun, getting closer and closer toward totality. And again, this is an opportunity for us to remind folks, regardless of whether you're watching this right now in Oregon or if you're anticipating the beginning of the eclipse from another location in the U.S. or really across North America, wherever you're able to view us from, that it's important that you have to have those safety glasses. We cannot stress that enough. We've been getting a lot of questions on social media, people just emailing us asking about that. You must have the glasses unless you are in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Weil, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on a tree. There's some really wonderful ways of catching imagery of it. So, you know, be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little bit about the science that NASA's
We should, but
doing today,
before we do that, I just want to give a shout out to our website because you're talking about all these great ways to indirectly view it. And again, just a plug for the Eclipse2017.nasa.gov site where you can find all kinds of information, but especially some do-it-yourself instructions